Assalamu alaikum warahmatullahi wabarakatuh. Now I will start for tutorial application of integration. Okay, we will start with questions 1CD. So question 1C. Okay, tutorial application of integration. So for this question, we have to this one 1C. We have y is equal x to the power 2 over 3 x from 1 until 8. We have to find the arc length. So we need to solve this one. We have y equal to x 2 over 3 x from 1 until 8. Now dy over dx, to find the arc length you have to find dy over dx. So dy over dx is equal to 2 over 3 x minus 1 over 3 x minus 1 over 3. So you have L is equal to the integration by the rule from 1 until 8, 1 plus dy over dx square, which is 4 over 9 x minus 2 over 3 dx. So to integrate this one will be equal integration from 1 until 8, this one until the integration 1 plus 4 over 9 x 2 to the power 3 dx. So it will be integration from 1 until 8. So here we will make summation, so we have to use same denominator. So 9x 2 to the power 3 plus 4 dx. So we complete here. So this will be equal to integration 1 from 8 until the square root 9x 2 over 3 plus 4 over over 9x to the power 2 over 3 under the square root. So the root with the square will cancel each other, so you have x over 3 dx. So now you should have substitution 9x to the power 3 plus 4, then du will be equal to 2 over 3 x to the power 1 over 3 dx minus 3 dx, which is equal to 9 over 3, which is 3 times 2, which is 6 x to the power minus 3 dx. So now this integration will become square root of u. Du is equal to 1 over 3 times 6, which is 1 over 18. The integration here as a power function, u to the power is 3 over 2 times 2 over 3. Now in terms of x, you can repeat it in terms of x again and then substitute from 1 to 8. Then you can find the answer. You can continue to find the answer. Okay, so now for question 1D. Question 1D. Question 1D, also finding the arc length. Here we have this curve, 24 xy is equal y to the power 4 plus 48. Plus 48, and we have y from 2 until 4. We have y from 2 until 4. We need to find the arc length. So the arc length is, we have to first make x, because the integration of y, we have y is changing, the parameter for y is changing from 2 until 4, so our integration will be dy. So you have to write x in terms of y. So this one is equal, and it is easier also, y to the power 4 plus 48 over 24y. 24y. And this one will be equal to 1 over 24 y cube plus 48 over 24, which is 2 over y. Now I have to calculate, to evaluate the length, you have to calculate dx over dy. So dx over dy is equal to integrate this 1 over y, 3 over 24, which is 1 over 8 y square, minus 2 over y plus 2, the derivative of 2 over y here is as a power function, y to the power minus 1, so become minus 2 over y square. This is the derivative of 2 over y. Well, minus 1 become minus y minus 2, which is 2 over y square. So this is dx over dy. We need now to calculate the length. So to calculate the length, we have to integrate y changing from 2 until 4, the integral of 1 plus dx over dy square, which is 1 over 8 y square minus 2 over y square. Over y is dy. So now this one, to do this one, this is the integration from 2 until 4, 1 plus this one, 1 over 46 y to the power 4 minus 2 times 2 over 8 is 4 over 8, which is 1 over 2. 1 over 2. Y square times y over y square is 1 plus 4 over y to the power 4 dy. Okay, this one is the integration of 2 until 4. 1 over 64 y square, y to the power 4, plus 4 over y to the power 4 plus 1 over 2 dy. 1 over 2 dy. And this one is equal to square root. If you have a look here, we have, if I take the square root of this one, which is y square over 8, y square over 16 over 8, okay. plus 2 over y square plus 2 over y square dy, because this one is equal to y over 4, y to the power 4 over 46 plus 4 over y to the power 4 plus 2 times 2 over 8, which is 1 over 2. So exactly is this term. So this one you have to from 2 until 4. So now you have to integrate this one. 2 until 4, because the square root, the square will be cancelled with the root. So you have y square over 8 plus 2 over y square. 2 over y square dy. And then you can continue computing the terms. This is question 1D. Okay, the next question is question number, we have 1C, 1D, 1E. Also some students ask for question 1E. So for question 1E, we have y is equal to 1 over 10 x to the power 5 plus 1 over x to the power minus 3, and x from 1 until 2. We have changing for it. So now we need to find arc length. You need to find dy over dx by same method. Dy over dx is equal to 1 over 2x to the power 4 minus 3 over 6 is minus 1 over 2x minus to the power 4. So length will be the integration from 1 until 2, integration 1 plus this term square, which is 1 over 4x to the power 8 minus 1 over 2 plus 1 over 4 x minus 8. This one dx. So this one will be equal to the integration of from 1 until 2, because x is changing from 1 until 2, will equal to 1 over 4 under the integration 1 over 4 x to the power 8 plus 1 over 4 x to the power minus 8 1 minus 1 over 2, which is 1 over 2 dx. This one dx. So now this one is equal to the integration 1 over 2 until the square root. We have this one x to the power 4 over 2 plus x to the power minus 4 over 2 square dx. So, and 2 will be cancelled with a square, so you have only integration for x to the power 4 over 2 plus x to the power minus 4 over 2 dx. And then you can continue to get the answer. So now question 1, E, F, G, H, same idea. We can also solve number H, but E, F and G also same idea exactly. We can also H same idea, but we can solve it. H, we have 30x y cube minus y to the power 8 equal to 15, and we have y from 1 until 2. So I need to write x as a function of y. So x from here is equal to 1 over 30 15 plus y to the power 8 over y cube So now dx over dy is 1 over 3 15 over y cube plus 15 because this one still x. Okay, before doing the derivative, this one 1 over, we can say it 1 over 2y cube here plus 1 over 13 y to the power 5. So you will derive this one derivative is equal to 1 over y to the power 3 is 1 over 2 minus 3y minus 4 plus 5 1 over 13, which is 1 over 6 y to the power 4. This is dx over dy. So the length now L will be equal to 1 plus dx over dy square, which is 1 plus become 1 over 2. When you calculate it, 1 over 2, you will reach to this one, y over 8 over 36 plus 9 over 4 y to minus 8 dy. When you calculate 1 plus dx over dy square, you get this answer. Okay, so this one same will be the integration here from 1 until 2, from 1 until 2. This one will become y to the power 4 over 6 plus 3 over 2 y minus 4 square dy. By same idea, you can continue. This is question 1e. Now question number 2. Question number 2, show that the arc length of y equal cos x is equal to 3 over 4. 3 over 4. So this one. Question number 2. Show that the arc length of y equal cos x from x until 1 and 2 is equal to 3 over 4. Okay, we can go try. So we have y is equal to cos x. We need to find the arc length. So you have dy over dx is sine x. I think this one easy integration because length will be the integral 1 plus dy over dx square, which is sine square x dx from 1 until 2. From 1 until 2. 1 plus sine square is the integral from 1 until 2 cos square x. And this one will be the integral from 1 until 2 cos x dx. Cos x dx. The integration of cos x is sine x from 1 until 2. So sine 2 minus sine 1. Maybe this is not equal to 3 over 4, but never mind, this is the answer. This is the answer. Maybe there's a mistake here. Okay. Okay, now question number 3. Question number 3 is easy one because it is already similar to 1c. Same curve. Similar to 1c. Okay, so for question number 4. Okay, go for question number 4. For question number 4, we have the function x. We need to use the substitution x sine t to prove this integration. Okay, we need to use this substitution. X is equal to sine t to prove 1 plus x squared dx. So when x is equal to sine t, this means that dx is cos t dt. Dx is equal to cos t dt. Okay, so now cos t dt, now the integration of 1 plus x squared okay, so 1 plus x squared dx, so this one will be equal to 1x squared is sine squared t. Now dx will be replaced by cos t dt. So this one is equal to 1 plus sine square is cos square under the square root by cos. Cos times cos, this one become cos square t dt. Cos square d dt. By using the identities, this one is equal to 1 over 2 integration to cos 2t plus 1 dt. Plus 1 dt. So this one will be equal to 1 over 2 cos tt is sine 2t over 2 plus t plus constant. So now you need to rewrite your integration in terms of x. You have to rewrite your integration in terms of x. So this one will be equal to 1 over 2 sine 2t is sine 2t is 2 sine t cos t over 2, so you have only sine t cos t plus 1 over 2. Here t is sine inverse x. Okay, t is sine inverse x plus constant. So I need to write sine t cos t in terms of x. So sine t is x. Same. Cos t is the square root 1 minus sine square t, which is 1. Sorry, cos t is the square root of 1 plus sine square t, which is 1 plus x square, plus 1 over 2 sine square x plus constant. So here we prove the first one, and from this one you can conclude that a square root of a square plus x square dx is equal to, if we take a outside, then integration, I take x square as a common factor, so 1 plus x over a square dx. So we can use similar formula to continue. To prove the second expression. And then you need to use this one to find the arc length of the parabola. So y is kx squared from x from 0 until x1 over k. Here you need to find dy over dx. Which is, and apply the formula. You have y kx squared, so dy over dx is equal to kx. So apply the formula, and then you can use this, apply the rule that the length is equal to the integration 1 plus 4kx squared. 4k squared x squared dx, and you can use also the same formula. Okay, this is how to, some tips how to solve question number 4. Okay, now question the next question is question number 6. Okay, for question number 6, I will not solve all the question actually. Okay, question number 6, we have 1, 2, 3, 4, 5, 6. So 6i, you need to show that this one is symmetric around x-axis, y-axis, and line equal to x. So to show that is it symmetrical around x-axis, you need to replace y by minus y. You change every y by minus y. Then if you prove that you have the same formula, then symmetric around x. And also to show that it is symmetric around y, you need to change x by minus x. To show that it is symmetrical around origin, you need to change both x by minus x and y by minus y. So this is to show x-axis symmetric. This is to show y-axis symmetric. Both of this one to show origin symmetric. So you need to check by yourself. For the line y equal to x, you need to change x by y and y by x to prove that it is symmetrical around the line y equal to x. So this is to check the symmetry, how to check the symmetry around x-axis, how to check the symmetry around y-axis, how to check the symmetry around origin, how to check the symmetry around the line y equal to x. For x-axis, replace each y in the equation by minus y to show if you have the same equation or not. If you have the same equation, then you have symmetrical around x-axis. If you don't, you don't have. To check the symmetric around y-axis, change each x by minus x. If you get the same question, then you have symmetrical around y-axis. Okay, to check the symmetric around origin, you need to change both x by minus x, y by minus y. For the line y equal to x, you need to change each variable x and y. The second one to show that the range is this one for sure, because we have here x square and we have y square. Okay, this one also I will just give you the tip for II. Here you have x2 over 3, for example, it should be 1 minus y over 3, which means that x square should be equal to 1 minus y over 2 3 cube. So x square positive, this one should be positive as well, should be greater than 0. So from here y is from minus 1 and 1. From here y should be from minus 1 and 1. Similar is x. So also sketching the graph, you need to do it by yourself. You need to make the table and so on. So I will only solve for you question IV and VI. So 6 IV I will solve for you, because 6 IV you have y is equal 1 minus x t to the power 3 all 3 to the power 2. You need to find the arc length. Dy over dx is equal to 3 over 2 1 minus x to the power 3 1 over 2 1 over 2. So now this one times here, because I have to make the derivative for this one also. So this one times minus 2 over 3x minus 1 over 3. So 3 with 3 minus 2 with minus 2. So this one is minus square root 1 minus x 2 over 3 over x 1 over a 3. 1 over a 3. Now going for calculating the length. So L is equal square root 1 plus dx of dy over dx square. Dy over dx square, which is 1 minus x 2 to the power 3 over x 2 to the power 3 dx. Okay, now we will use the same denominator, x to the power t over 3. So here x 2 to the power 3 plus 1 minus x 2 to the power 3. This one with this one will integrate each other, because you have only so you have here you can integrate from 0 to 1 and then multiply from 0 to 1, because he asked you x from 0 to 1 the question. So this one will be square root integration 1 over x 2 to the power 3 dx. Now this one is the integration from 0 to 1, 1x 1 over 3 dx. You can continue. Final answer is 3 over 2. 3 over 2. For VI you will use same VI 6 VI same, but your integration will be from square root over 4 until 1. That's all. Dx. Same integration, but the boundary will be changed only. The boundary will change only. Okay. For 6 I, your graph, you can draw the graph, but your graph have this curve. Your graph will have this sketch. This is for question number 6. This is for question number 6. Okay, so now question number 7. Question number 7 for the same tutorial. Question number 7C. Okay, here you need to find the arc length for this parametric equation. For this parametric equation, you have x equal cosine cube t, y is equal to sine cube t. So here to find the arc length, dx over dt is 3 cosine square t sine t minus sine t. dy is 3 sine square t cosine t. So your length is equal to square root dx over t square, which is 9 cosine 4t sine 4t plus this one integration from 0 to pi over 2 plus 9 sine 4t cosine square t dt. So this one integration from pi over 2. Okay, so 9 cosine square t sine square t is equal to cosine square t plus from here sine square t. And this one is 1. This one is 1. So you have only integration from 0 pi over 2 9 sine square cosine square t sine square t dt, and this one is easy integration, 3 cosine t sine t dt. So you can continue evaluating this one. This is for question 7C, sorry. For question 7D, if you try to solve the question 7D, you have x is equal t cube over 3, y is equal t square over 2, t from 0 until 1. So after you calculating the derivative and so on, you will find the length is equal to, I will make the integration for you. The integration will be equal to t to the power 4 plus t dt. This is your integration from 0 to 1. So this one from 0 to 1, t square, so t square plus 1 dt, which is equal t square plus 1 dt from 0 to 1. So this one you take the substitution, t square plus 1, then du will be 2d dt. Then you can continue. Okay, now for question 7E. 7E same, exactly. 7E is same. I think it is easy. Now you have the question maybe 7F. Question 7F is similar. You will get 7F. You have x is equal to 1 plus t square. Y is equal to 1 plus t cube. Then after you calculate the derivative, you have this integration from 0 to 1. The derivative of x square, which is 4 1 plus t square. And then after you calculate the derivative of y and make a square, you have 9 1 plus t square dt. So t to the power 4. So now this one's integration from 0 to 1. 1 plus t square outside. Here 4 plus 9 1 plus t square dt, which is integration. Now 1 plus t square under the root become 1 plus t square root only for 4 plus 9 1 plus t square dt, 1 plus t square dt. So this one from 0 until 1, this one take the substitution, u is equal to 4 plus 9 1 plus t square. Take all this value equal to u, then du will be 18 1 plus t dt, 1 plus t dt. This is the idea of question 7F. 7G, okay, 7G, I will give you the integration also. 7G, you have x is natural logarithm cosine 2t, y 2t, calculate the derivative and so on. The derivative dx over dt here will be equal minus 2 tan 2t, and here dy over dt will be equal to 2. So length will be the integration from 0 until pi over 6. This one square, which is 4 tan square 2t plus 4 dt. And this one integration, 4 outside become 2 tan square 2t plus 1 dt. And this one from identities is sec square 2t. Sec square 2t, so you can continue. Okay, so it will be equal to integral sec 2t dt. And this one is equal to natural logarithm sec 2t plus tan 2t, like this. This is your integration. Now you have to substitute from 0 to pi until 6. You have to use this substitution. Also for question I, same ID. Question I, same ID. 7I, same ID. Okay, for question 8, for question number 8, find the Cartesian equation for the form in exercise 7c. Exercise 7c, we need to find, okay, exercise 7c, this is the parametric equation, x cosine cube t, y sine cube. This is the question 7c. So you need to find the Cartesian equation for this one. The Cartesian equation for this one. So to find the Cartesian equation, take x to the power 2 over 3 here will be cosine cube t to the power 2 over 3, which is cosine square t. Y to the power 2 over 3 t is equal to sine, because y is equal to sine cube t. So to the power 2 over 3, 3 will divide by 3, so it's sine square t. So x2 to the power 3 plus y to the power 3, which is cosine square plus sine square, which is 1. So this is the Cartesian form. This is the Cartesian form, and we can use this Cartesian form to find the length. We can use this Cartesian form to find the length, as we did in question 6. Or we can use the parametric form. In question 7c, we use the parametric form. In question 6, we use the Cartesian form. Okay, for question 9, okay, I will go for question 10 first, then 9 later. I will go back for the question 9 later. Let us go for question 10. Question 10. Question 10. Okay, question 10. Question 10, we can solve B. Go B. Question 10b, we have r is equal to a cos theta. R is 2a cos theta. And we need to find the arc length. So this is the polar form. This one is the polar form. And we need to find the arc length. So the arc length here for the polar form, you have to find dr d theta. This one actually is a circle. This one is a circle. Okay, dr d theta is equal to minus 2a sine theta. This is a curve of the circle. This is the center for the circle, which is a0. So here to integrate, I will integrate from 0 until pi over 2 in the first quadrant, and I will times by 2. So this is, so the length is 2 from 0 to pi over 2. Instead from integral from minus pi over 2 to pi over 2, I will integrate over the first quadrant from 0 to pi over 2 and will times by 2. Now here's applying the rule. R square is 4 a square cosine square theta plus dr over d theta square is 4 a square sine square theta d theta. So this one become 2 from 0 until pi over 2. This one become 2a because cosine square plus sine square is 1. So under the square root 4a square is 2a d theta. So you have 4a theta from 0 to pi over 2. To pi over 2, so it's equal to a pi. 2a pi. This is question 10b. 10b. Now for question 10c, I think easy, have no problem. For question 10d, okay, can check question 10d. Question 10d. Question 10d, you have the r, because question 10d also you don't have the, okay, r is equal a 1 minus cos theta. They didn't give you the boundary, so you need to know the boundary by yourself. So here dr by d theta is equal to a sine theta, because the derivative of cosine is minus sine and we have minus outside, so become a minus theta. So the length will be r square, which is a square 1 minus cos theta square plus dr d theta square a square sine square theta d theta. Now this is the curve. If you make a plot for this one, this is the curve. Okay, so here I will integrate from 0 to pi and I will multiply by 2 to find the length. You will integrate from 0 to pi and multiply by 2 because you have symmetrical around x-axis. Now this one, this integration, after simplification you need to find from 0 to pi. If you evaluate the square here, you will get 2a square. You will find this one. After simple calculation, you will get this one. This it. So now this one, L will be equal to from 0 to pi 2a. Now I have this identities that cosine theta is equal to 1 minus 2 sine square theta over 2. This is identities. So from here 1 minus cos theta is equal to 2 sine square theta over 2. 2 sine square theta over 2. So use this one to find that 2a square will become 4 a square sine square theta over 2 d theta. And this one 2 from integration 0 until pi 2a sine theta over 2 d theta. So this is assembly integration and you can continue. Your final result is 8a. This is the final result you have to get. Okay, so now question number 10. We already solved 10 number D, so now we will go for 10E. 10E I will not solve, but okay, 10E, same idea like the others. We have R here to theta. Okay, theta from 0 to pi, but maybe because the final answer and the dr over d theta is d theta ln 2, natural logarithm of 2. So after you applying the rule, you will get that the length is from 0 to pi square root of 2 theta 1 plus ln square 2 d theta. Okay, so this is a constant, this one is a constant, so this one 1 plus ln square 2 constant under the square root. So you have integration from 0 to pi 2 theta d theta. So this one after calculation will be equal to the square root 1 plus ln square 2 times this one 2 pi minus 1 over ln 2 over ln 2. Okay, because this one will be different, I think, from the final answer on the file. Okay, now for question 10F. 10G is okay. 10F only I will give you the integration, how to do the integration. 10G, because I think you have problem in the integration, maybe, I don't know. 10G is 10F. Sorry, this one is 10F. 10F. 10F R is equal to 6 1 plus cosine theta. Theta from 0 until pi over 2. So dr over d theta here, you calculate this one. Okay, 1 plus cosine theta square 6 sine theta, because this one square, this one times the derivative of 6 is 0, minus 6 derivative for the 1 plus cosine theta, which is minus sine theta, so minus minus become positive. So the length is the integration of r square, which is 36 1 plus cos theta square, plus dr over the theta square, which is 36 sine square theta over 1 plus cosine theta to the power 4 d theta. So this one I will take 1 plus cosine theta square as a common factor outside the root, so become 1 cosine theta here. So here we have only 36 plus 36 sine square theta over 1 plus cosine theta square d theta. So now this one become you can take 6 outside also, so 1 plus cosine theta here you can make 1 plus cosine theta square 36 because we take 6 already outside, 36 already outside, so become 1 plus cosine theta square plus sine theta square d theta. So this one out of the square root, so 6 of 1 over cosine theta square. Here under the square root I have 1 plus 2 cosine theta plus cosine square theta plus sine square theta. This one and this one is 2, so 6, 1 plus cosine theta square is 2 plus 2 cos theta d theta. 2 plus 2 cos theta d theta. So this one length will be equal 6 square root of 2 1 over cosine theta 3 to the power 2 d theta. 3 to the power 2 d theta, and this one using the identities 1 plus cosine theta will equal to 2 cosine square theta over 2. Cosine square theta over 2, so you will have 6 square root of 2 over 1 2 cosine square theta over 2 3 over 2 d theta. Okay. 6 square root of 2 over 2 over 3 over 2 here, integration cosine square to times square, so become cosine cube theta over 2 d theta, and then you can continue. This is the integration of sec cube. This one will be sec cube theta over 2. So you need to integrate sec cube theta over 2. This is for question 10F. Okay, for question 11, find the equation in polar coordinates. This one x e t cos t. This one in parametric form. You need to find it in polar coordinate. So this one you need to change to Cartesian first. You have to change this one to Cartesian first. So to change this one to Cartesian first, you have x square plus y square is equal e for t. And also you have y over x is equal to tan t. So t is tan inverse y over x. So here this one x square plus y square will be equal to exponential 4t, which is tan inverse y over x. So this is the Cartesian form. To change it to the polar form, it becomes r square e to 4 theta. This is the equation, which means that r is equal to 2 theta. You need to evaluate the integration for this one from 0 until 2 pi using the polar formula. This is question number 11. For question number 13, we have question number 13H. Okay, question number 13H. Y is x square over 2 plus 1 over 2 from x until 1. Okay, this one we need to find the area around the x-axis, revolving around the x-axis. So I have function y is f of x, so the formula is, and the rotation is around y-axis, so the formula is integration 2 by x, because I have y is equal f of x and the rotation is around x-axis, so 2 by x integration 1 plus dy over dx square dx from 0 to 1. So this one from 0 to 1, 2 by x 1 plus dy over dx is x square, is x. dy over dx is x square dx. So this one, use the substitution. Take q is equal to 1 plus x square, then du is 2x dx, and then you can continue, For question 14, you need to prove that the surface area of the cone, you have a cone. Cone means you have right circular cone. Right circular cone. If I have this one rotate, this one is R, radius R, and height h. And this one make a rotation to make a cone. Make a rotation to make a cone. We need to find the area of this cone. So you need to find the function first. We already, this is our function, this line. This line, this is the point RH. This is the point 0, 0. If we find the equation of the line will be y is equal to r over hx. So this is our function. Okay, so this is our function, rotation around x-axis. Rotation around x-axis. So as x will be, okay, r is from x is from 0 here until r, from 0 until r, 2 by f of x, which is r over hx, 1 plus dy over dx, which is r over h square dx. So this one, 2 by r over h, square root 1 plus r over h square. This one all are constant. So you have to integrate only x, which is x square over 2 from 0 to r. So this one with this one, you have pi. Okay, we have first r square. Here you have r square. Okay, I think there is a mistake here. This one should be the radius. This one should be r. Okay, sorry. Okay. So this one should be this one the radius r. This one should be h. So the point here is hr. So that the slope with r over h. So the slope of theta is r over h. So here with our integration for x from 0 to h. From 0 to h. So now we have pi, okay, r over h, 1 plus r over h square, and minus 0. So this one, if we arrange it, we have pi r. Okay, h square over h is h, multiplied by 1 plus this one, make it h square plus r square over h square. So this one with this one, we have pi r square root r square plus h square. So this is for question 14. Okay, now for question 15. Question 15, you need to set the surface area of the sphere. Sphere, which means that we're rotating a circle. We're rotating a circle with radius a. From minus a to a, we have a circle. We rotate this circle. So for this rotation, the equation of the circle is x squared plus y squared is a square. So your function is y a square minus, this is the equation of a circle. This is the equation of a circle. So here I will rotate. We will rotate around, I will take half here around y-axis. I will take this one and I will make it a rotation around y-axis. So I will integrate, okay, rotation around y-axis. So you will have 2 by x, okay, 1 plus dy over dx square, which is when if you integrate this one and take the square, you have x square over a square minus x square dx. Now x here for this part is from you can take from 0 to pi over 2 multiplied by 2. I will take x should be from minus pi over 2 to pi over 2, but I will take it from 0 to pi over 2 and multiplied by 2. And then we can calculate the integration. You will find that the integration here from 0 to a, because x, the integration is x not y, so you have to choose x. So x is changing from 0 to a, because this is dx and the rotation y, so the integration from 0 to a, then you calculate this one, you find that it is 4 pi a. This one we will use the substitution to do the integration. U is a square minus x square, then du is 2x dx minus, but you need here to make the summation first. We do similar one in the previous questions. So this is question 15. For question 16, this is your curve. I think we did this one before in question 6. Same integration. Okay, you need to calculate, because this is your graph from 0 to 1. So this is the graph, and then you will integrate from 0 to 1. You will need to calculate here. Y is 1 minus x 2 to the power 3 over 3 to the power 2. This is your curve, so you need to find dy over dx, similar to question 6, and then use the formula rotation around x-axis from 0 to 1. Rotation around x-axis, 2 by f of x, 1 minus x, 1 plus this one square, dy over dx square dx. So this one similar to question 6. Okay, 18, no problem, no need to do this one. Question 18. Question 21, the final question is question 21. Question 21, you have x square plus y square is a square. This is a circle. This one is a circle from minus a to a. So if you have 2 points, the first point C here less than a, the first point is B bigger than minus a, and we need to rotate only this portion. This portion will be only rotated. So what you need to know is the rotation around x-axis. So y here is minus a square minus x square under the square root. So dy over dx is minus x over square root a square minus x square. So you need to find the rotation around x-axis. Rotation around x-axis, you will integrate from b to c, 2 by f of x, which is a square minus x square, 1 minus or 1 plus dy over dx square, which is x square a square minus x square. So you can multiply these two roots together and continue. So this is for question 21. Okay, so here I hope I can go through for most of the questions required. Any extra question, you can WhatsApp me. I will try to solve as much as I can. Thank you for all of you.